Good evening, dear friends. It's me, Ishita, and welcome to the session 2 of the Spot Virtual Classroom. I hope you all are having a good day and excited to listen to the next topic, Earth Science. Earth science is the study of Earth's structure, properties, process, and 4.5 billion years of biotic evolution. Understanding these phenomena is essential to maintenance of life on the planet. In general use, the term earth science often includes the study of Earth's atmosphere, meteorology or atmospheric science, earth flowing, the water flowing on and beneath the surface of the continents, hydrology, and the Earth's seas and oceans, oceanography or ocean sciences. The knowledge gained and the services provided by Earth scientists help society cope up with its environment in many ways. Their knowledge about the structure, stratigraphy, and the chemical composition of the Earth's crust helps us locate resources that sustain and advance our quality of life. Let us delve more into the topic Earth science. Respected principals, teachers, and students, I'm delighted to introduce and welcome Dr. S.K. Varshney, Senior Scientist and Head of International Cooperation, Department of Science and Technology, Government of India, a highly motivated and hardworking research geologist with a PhD in hydrological studies and a master's in environmental sciences. Dr. Varshney possesses a wide experience of conducting multidisciplinary tasks on the hydrogeological domain, combined with solid management skills acquired during years of work as an administrator. We are overjoyed to have you with us, sir. Now, may I please welcome Dr. Varshney to address the spot talents on today's session, Earth Science. Please, sir.
Yeah, thank you very much. In fact, I thought I would be sharing with all the excitement what geology can offer and why we are studying this science. I hope you can see the presentation.
Screen is not visible, sir.
It's still not visible. Just a moment.
Okay, sir.
Yeah, now you can see it.
Yes, sir.
Okay, so Earth, as we all know, is one of the planet on the Earth and on in the galaxy. And right now, it is the only planet which has life in it. How Earth is different from others? How can we know more about Earth? We are going to learn today. And what you was told in the preamble that Earth science includes all field of natural sciences related to Earth. It deals with physical and chemical constitution, also its atmosphere. And if we see it from a broad angle, then it is one of the planets. So planetary science also, uh, Earth science is part of planetary science. Within Earth science, of course, there are several things, but there are lithosphere on which most of us are living. And lithosphere is the solid part on the top surface. We are living, so some of us are living in plains, some of us are living in mountain or hills, some of us are living in valley. So we could be living anywhere, and wherever is the ground surface of Earth, it is called lithosphere. And then, as we all know, we are surrounded by water. So nearly 70% of the Earth is covered by water. And water has different forms. Water in river is different from water in ocean. and water in rains, water in glaciers. There are several forms water could be, and that is what we study in hydrosphere. Now, then there is atmosphere, which we see up above the sky. And normally, whenever we are talking about atmosphere, although from here we see only the top layer, the blue sky or night sky, dark night sky. But then in between, atmosphere is also divided into several layers, and each layer works in a different way, has different property, and then we look for. Now, if we combine hydrosphere and atmosphere together, this forms the water cycle. How do we get rains? How do we get drought? How do we get flood? It's the combination of various parameters we study in hydrosphere and atmosphere. And then what are the species that could survive on the planet Earth is something we are studying in biosphere. Now, I hope all of you are aware there were certain species, for example, the most famous one, dinosaur, which used to live on Earth, but it's not there. So we study in biosphere what kind of species could survive, sustain themselves on the Earth. And cryosphere is the study of very low temperature, so like Antarctica, Arctic, even some part of Himalaya, which is going in very low temperature. We know what could be the living conditions there, how several biological species, be it animal, be it plants, how could they survive? So this is what we mostly study in earth science. And if you see what are the different sections, then we could divide earth science into geology, which is study of solid earth, oceanography, only studying the oceans and seas, meteorology deals with meteorology deals with earth atmosphere, and astronomy deals with something beyond earth in our universe, in our galaxy. So wherever we could find and how we could contribute over. If we see earth interior, then there are three major layers: the crust on which we live, the mantle, the intermediate layer, and the core, where we feel that there is a lot of nickel and iron. Now, crust is basically constitution of silica and aluminum. It is also called Cl, Si for silica, and Al for aluminum. So it's called Cl. Mantle is called Sima, silicon, magnesium. But if you see a little bit more, then you will realize that these three layers could further be subdivided. And now I would like to ask you a question. Did you read something about Earth interior new discovery in last month? If not, please do look at the newspaper on 28th, and I would love to discuss that when we are having the discussions. Uh, your doubts, whatever they are, how I could explain them. But I would like you to read about something new which we have learned very recently about Earth interior. Now, composition of Earth, there are solid layers and liquid layers. And liquid layers are molten material. So this is quite hot. And how this molten material affects, of course, one is that we get volcanoes. Now, volcanoes could appear on the Earth's surface, but there are a lot of activity inside the Earth also. So inner core is supposed to be white hot, and pressure of is so high that iron cannot melt. Now, imagine a situation that if I need to get my shirt iron and I don't have iron at home, so what I will do, I'll fold it in a way, put it under my pillow so that it can have some kind of pressure. But what happens if someone puts weight on your shoulder? How long you can survive? Can you tolerate half a kg for half an hour? It's impossible. And imagine that deep down the earth, the inner core has to be a huge load of solids and liquid, which are as high as 2,400 kilometers. So quite a large part, and that creates pressure and also temperature. I think all of you know that we are the third planet from the Earth. We have Mercury and Venus before us and Mars after us when we see it in terms of distance from the sun. Have you ever wondered why all of the Earth is not seen? You will find a lot of undulations, lot of different in soil structures, lot of difference in topography. Why it is so? And you will find somewhere very colored landforms, and they are in the layers, one after another. So how does it could have happened? And then have you seen such streams of waterfalls which has their very defined channel, and only in those places they are flowing? So we need to understand through our studies how and why this is happening. And do you know that the highest mountain, we are proud to have Himalaya with us, it is located in a specific belt. And why this belt, we'll discuss a little later in my presentation, that Himalaya is constantly rising and why it is rising. And when it is rising, how does it affect the other part of the country? And I hope all of you have seen the map of the world. But have you ever thought that this is something which could be a jigsaw puzzle? Suppose this part of Africa, uh, western part of Africa, sorry, western part of Africa and eastern part of southern America, they could be combined. Similarly, North America could go and fit over Africa and Europe, and Australia could fit in over Bay of Bengal area of the India. So there is a possibility which is we can imagine just by seeing the map that it could be there. But then is it same all the time, or these continents are moving? This is something a questions which we need to understand into low. And I'm sure all of you are aware. Recently, we had a earthquake in Turkey and Syria. We lost a lot of life. This picture, of course, is from India, from Burj earthquake. But just to make you feel that how does Earth releases energy? Earthquake is one of them. And when intensity is high, we are measuring it on the Richter scale. When there are earthquake of 6 and more intensity, the Richter scale, then large scale damages are there. And if it happens in the populated area, then there is loss of human loss, as we saw in Turkey, where it is expected that more than 40,000 people lost their life, besides several other things that have happened. And have you heard about tsunami? Well, India got one tsunami quite some time ago, but Japan gets it very often. Tsunami are caused because of earthquake in the water, in the sea area. And what happens? It provides a lot of energy to waves, which moves at a much higher speed and at fly, so the wavelength is quite high, so that it impacts in a very damaging way to the society, to the civil infrastructure, to the road infrastructure, whatever we have created, and makes life a little bit more miserable. And then we have volcanoes. So of course, this picture is from Andaman and Nicobar, Barren Islands. But then I would ask you, what are 2 or 3 volcanoes, if you could remember, which have erupted in recent past? And I would be too happy if you tell me that these were the volcanoes which erupted in last couple of years, and how does it impact on the human life? And then if we see earthquake and volcanoes, they have a very interesting relationship. That most of the volcanoes occur at places which are close to the area of earth. Now, all earthquakes, for example, are not because of volcanoes. Volcanoes are one of the major reasons. But what it denotes, it means that these are the weak zones on the Earth's surface, which has a possibility of leakage from inside. So lava could erupt from there. And we are calling all those areas marked in orange as ring of fire. So we know these are the area most vulnerable to volcanoes. Now, if you see in this map, two maps on India, then India, you will find a lot of earthquakes are there in the northern India, but volcanoes are not there. So the reason for this is, we'll discuss a little later, but idea is that there are tectonic activities. And these tectonic activities, because of these tectonic activity, Himalaya remains active and gets so many volcanoes. We have a study which says that nearly 8 years, somewhere in Himalaya, there would be a major earthquake. So it could be in Uttarkashi, Chamoli, Nepal, anywhere it could be. So we need to be cautious about it. And then Earth has got a very, very unique phenomena, which is called Earth magnetic field. Now, of course, we have made a lot of studies, and it has been helping now all of us. Normally you would carry a compass, but then currently all the navigation, be it aeroplanes, be it ships, or even the cars, they are being driven using the Earth magnetic field. Because whenever we open even Google Map on the car, or a pilot sees in which direction plane is flying, they use this property. And this property is that if you put anything like which has magnetic impact like iron, then it will automatically adjust itself into north and south direction. And then you can rotate yourself, and where you want to reach accordingly, you can set if you want to go 10 degree north, 10 degree south, 20 degree north, 45 degree east. So accordingly you could adjust. And these are something very spectacular, very romantic. And what is happening that when water flows through rocks which are water soluble, so it drops one by one in the cave and give structures to these features. Again, I think you should remember that people get into different perspective. Religious feeling says these represent some creation, magic creation of the God, and we go through several religious rites. But I would like to tell you, these are absolutely natural phenomena. Whenever river is flowing through the water soluble rock, especially in caves, so you will find such a structure because of seepage. And these structures, as the water drops, could come either from top to bottom or bottom to top. How it comes from top to bottom? Water keeps on dropping, temperature is less, so it gets frozen. On the other hand, sometimes you will find that water is dropping from the top and it does freezes in the way. So it develops then top to bottom structure. You might have heard a lot about the climate change, and we are being alerted that Earth's temperature, average Earth's temperature is increasing by 1.8 degree, and there would be a lot of consequences, like water level in the sea will increase. Some of the countries, some of the islands may get submerged. And here my question is, do you know one of the islands which got, one of the Indian islands which got submerged into water in recent past. And I can give you a hint, it got submerged when India got tsunami. So you should Google it out, you should read about that island, what is something we lost. And if water rises further, what are our vulnerable areas? And then, of course, we need to worry about the neighborhood, about the other part of the world, which may get affected if sea level rise. And also, climate change impact is not only restricted to that, it also impacts our agriculture because farmers need to plan. Now, earlier we were calling Rabi crop, Jaid crops, Kharif crops, a specific timing when you can sow in, you can irrigate them, and then you can reap them. But now, because of changes in the water cycle, change in the rain cycle, we are not getting rains which were predicted earlier. So farmers need to adjust. And once they adjust, then they could go ahead. Now, the, if you see the time since the industrial revolution has come, human being has done a lot of damage to the atmosphere. We have added a lot of toxic gases into the atmosphere. We have added a lot of chemical leaching into the subground system or underground system, and water has got polluted. And then we need to see if this climate change is happening naturally or it is contributed by human beings. Also, we need to see if it is the isolated event or in the history of Earth, climate has changed many, many times. And again, it comes when we talk about formation of Earth. This is a very, very unique planet, but only planet known so far to have life. And why we are alone in this universe? That is what has been bothering man. And we are looking for signature of life on other planets. Now, we have good study of planets in the solar system. But then in other galaxies, is it possible to have life? That is what is challenging. That is what researchers are working upon. And then for you, it is important why Earth only has got life. What makes life to begin on Earth and how and when it got evolved. So we need to understand in this process. So if we want to answer all those questions which we have seen so far, then you need to be a good student of physics, good student of chemistry, and good student of biology, as well as your observation power should be very important. And that is how you can make to yourself ready to understand various natural processes. Now, a lot of imagination is required to handle different kind of data, but then it is possible you can do it. So if we see about our own Earth, how did it became, how did it came into existence? So we all know that there was a nebula, and that is where the Earth formation started. And if you see our galaxy, Milky Way galaxy, this is the artistic impression which was created by Benjamin in 2008. This is how the galaxy of which we are a part looks like. And if you see the family of our solar system, if we come down to the level from galaxy to our solar system, then this is the new solar system we are part of. And if we see from outside, so there are two pictures, one taken from the surface of moon and one just from outer surface, how Earth looks from a distance. Now, remember, Earth represents only 0.2% of the mass. If you see, there are planets bigger, much bigger than Earth. You see the dimension of Earth, and you see dimension of planets in the outer solar system, which means away from. So, except Mars, all other planets are much, much bigger than Earth, be it Jupiter, Saturn, Uranus, or Neptune. We are unique among the terrestrial body to have a good amount of atmosphere, and our atmosphere is composed primarily of nitrogen and oxygen, and it is carbon dioxide. 75% of atmosphere mass is within first 11 kilometers. So if we see it from now where we are standing, go up in the sky, the first 11 kilometers constitute constitute nearly 75% of the atmosphere. And then two-thirds of the Earth's surface is covered by the ocean. Now, if we see how the solar system and differentiation of Earth might have happened, then it was condensation of dust and cloud which started, formed into nebula, solar nebula, and then lot of formation of planetesimal leading to formation of protoplanet, and then there was heating and differentiation started in form of core, mantle, and crust. And how do we know about these things? So we need to uh, date meteorites. I hope all of you know what is meteorite. These are rock surfaces from other planets that keeps falling on Earth. And based on the aging we have done of these meteorites, we can predict that Earth is nearly 4.6 million years old. These, uh, and how do we know about the inner Earth, like crust, mantle, outer core, inner core? So we are doing in surveys. Now, of course, there is no hole we have done in the Earth's surface which could touch even the mantle. So how we are doing it? We are doing it indirect ways. We are studying the earthquake waves, seismic waves they are called, and uh, seismic waves are of two types, primary and secondary. Primary waves are compressional, they can pass through liquid, and secondary waves are shear waves which cannot pass through liquid. So when we release such waves, seismic waves, from station A to station B, then we try to see what is being received. And based on the information, we calculate depth, we calculate strength, thickness, and we mark it. So Earth is a dynamic planet. It keeps evolving. There are changes in the life form, and we should not presume that all life which Earth started with would be retained till now. Several lives are changed, and Earth is a dynamic process. And then the biggest discovery of the last century was discovery of plate tectonics, which says that all the planets are constantly moving. And these yellow lines shows the plate boundaries, which may not be identical to the continental boundaries, but they are somewhere in the sea, and they keep helping. Now, one of the reasons why Himalaya tectonic activities are active is that Indian plate is pushing into Asian plate. Now, India, sometime it was on the equator, but it has taken a northeasterly movement, and we are now crushing with Asian plates, and that is why we have got Himalaya. So I would suggest that each one of you take some two soft things, try to push, and then see what happens. And then you will realize how Earth's surface could have folded and formed into Himalaya. Now there are three kind of movements. It could be drifting away from each other's, or it could be moving side by side, or it could be vertical direction, vertical, horizontal. So it could move in either way. There are several examples how plate could move. And what makes the plate dry? So Earth is constantly cooling right from the time of formation. Lot of heat is generated by radioactivity, and heat is transferred through convection. Now, if you have seen how we are warming up, how we are preparing tea or warming up the water, and if you could see movement of the water molecule, so near the heat source, which could be gas burner, you will see that particles which are closer to the surface will move up after getting heat and will give space to those molecules which are colder than them. This process keeps on going even in the plates. And then hot matter rises from the planet, causing plates to form and diverge. And when plates converge, cool plate is dragged into the neighboring. So constant process is happening. Earth is a very, very dynamic planet, and several activities are happening below the Earth's surface. And then this is another aspect of plate tectonics, that Earth, Antarctica, which was sometime on the equator, has now moved to polar zone. Indian subcontinent was southern hemisphere 250 million years ago. Now we are completely in northern hemisphere, and continents are constantly changing their position. If we look at history, then we have got a history of near more than 550 million years. And there are activities which shows that even in past, there is change in the Earth's temperature. So we have had warm period, and also we had the ice ages. So if we see a lot, the first uh, fossils which we know has happened in the Cambrian period, nearly 400 million years ago. But then you should imagine that life has constantly been uh, progressing, evolving. And how do we record? We study the fossils, which tells us that what was the life in that period. We can date the rocks using the minerals in that rock, and that is how we can give age to a particular species when they would have lived on this planet Earth. So you see this particular thing where we have this is basically since the Cambrian time, and we are saying anything before Cambrian as pre-Cambrian, and how life has been evolving. So we have got the first fossil from nearly 540 years age. Fish has come much later, and then vascular plant. So life started from the unicellular and then bicellular, then multicellular animals like has come. And now we are living in a Pleistocene age just after the this thing. So if you look at what does Earth science offer, there are several areas you can study: planetary science, atmospheric science, solid state, oceanography, and paleoceanography. Paleo is a very important word which we are using for geological history, geological past. Then we have got hydrology, which studies about the water system, climate and paleoclimate studies, biogeochemistry, environment, and applied geoscience. So a lot of scope is there in this branch of science to understand. And when we see how does Earth interior works and how does it affects the surface, then you can see that there are volcanoes which are a window to the mantle because they bring in material from the Earth mantle, which in addition to our seismic waves provides us the direct tool of what is inside the Earth. And then there are several elements which are radioactive, and through them we can study the rock and find the age of that rock. So one is biological parameters. We realize that such and such life happened in such and such period, and then we can study the age of this thing using several radioactive elements. And we know how much radioactive elements, what is the half-life, and if they are there, how it could have gone. And if you see again, trying to put together all the continents, how did that transformation of movement started? So it started nearly 116 million years ago. And before that, there used to be two planets, Laurasia in north and Gondwana in south. Have you heard Gondwana? This term has come from India. In Madhya Pradesh, we have a home to Gonds tribe. And by all that, this area was known Gondwana. And Gondwana is rich in hydrocarbons. We get a lot of huge gold deposits. But then we are also using various animals. For example, elephant. Elephants you find only in India and Africa and not in other part of the world. It shows that once upon a time, India and Africa were together and animal could have moved. And then there are several other animals like that. So we could make out how what are the continents which were connected and where this particular species could have grown. And then I think all of you might have seen the movie Jurassic Park, and it shows us that the biggest creature on this earth was lived is dinosaur. And even in India, we find several places that the signature of dinosaurs through its eggs, through its skeleton, and we are making good use. But what happens? It is uh, observed that there was a huge volcanic eruption on the Earth's surface, which did not allow even sun to come to Earth. So sun rays could not come. Earth, imagine if there is for a day or two there is no sun, how dark we feel. And if sun is not there for a long period, it is expected that the period was roughly around 3 years when sun rays could not reach Earth. There was no growth of vegetation, and bigger animal who could not survive that kind of environment died, and eventually we got extinct. In India, we have found signature of dinosaurs and the associated volcanic activity, which probably led to its extinction in areas close to Deccan Trap. So Deccan Trap is an area roughly from Bombay to Jabalpur to Hyderabad. And here we get a lot of species. Sometimes we get some useful fossil also. And then we are also doing iridium testing, and that helps us in dating this development. And if you see the volcanoes which are also happening, this is from Andaman, and here we could know which is the cone from where the liquid is coming up, what is it, and where it is spread is called lava field, and then we see the rim all around. And this is a picture taken from Barren Island once again. And here the idea is that this picture on the right, which you see four gentlemen standing, they are standing at a distance, not very close to the volcano, at a distance. And picture is taken. And then several kind of rocks get formed when they come out on the earth. And it is possible to date them, and different part of the rock could be of different age. And this is done based on radioactive element dating. So Earth's science is quite fascinating. It helps us to understand origin and evolution of our own planet, and of course other planets and other bodies in our solar system. It keeps us close to the nature. It is most spectacular and challenging places it makes, and then it makes us most creative scientists, and it requires out of box thinking, and you should have a fairly good knowledge of different sciences. If you want to make a career in earth science, you can do BSc BTech in geology, physics, chemistry, or civil engineering. You could do MSc or MTech in this thing. And then there are several players, especially the biggest one is Geological Survey of India, ONGC, Oil India Limited, Coal India, Mineral and Exploration Company, BAR, ISRO, and private. And besides, you could have career in universities, IITs, ICERS, Department of Space, Ministry of Earth Sciences, Council of Scientific and Industrial Research, and DSC. So with this word, I would like to close. And now I will wait for your questions, which we can answer at a time notified by the center. Thank you very much.
Thank you for the wonderful session, sir. Q&A session is rescheduled at 5:30 p.m. on 7th March 2023. Your questions should reach us latest by 6 p.m. on 6th March 2023. Please use the link on the spot link page of VSSF website to raise your questions. Dr. Varshney will come live on 7th March to answer your questions. Please pay attention to these important points. Limited time restricts our speaker from taking all questions that come through. Speaker will shortlist few relevant and contextual questions that we receive. Questions that are similar in nature will be clubbed to a single question. Our endeavor is to ensure that you get better clarity on the subject. I'm extremely thankful to you for your valuable time and insights. Sir, thank you, sir, principal, coordinators.
Thank you.
We shall see you at 5:30 p.m. on 7th March 2023.
Thank you. Bye for now.